Good morning, good afternoon, good evening, and depending on where you are in the world. I'm Mark Richardson. I work for Troup Bywaters Ander, or TB&A for short, who are an engineering partnership. We do design and, as importantly, operation of buildings. And within the partnership, I'm the head of sustainable innovation. And I'm here to talk to you today on designing smart buildings for sure, but also how to effectively realize those designs in operation and really get the value for what we do. Okay. So I'll start my conversation today with a quotation and a controversial statement. So the quotation was by a chap called Albert Einstein, who I'm sure you're all familiar with. And he said, "If I were given 1 hour to save the planet, I would spend 59 minutes defining the problem and 1 minute resolving it." So just think about that while I go into the controversial statement. My controversial statement is that the PropTech industry and the smart building industry is actually not very fast moving at all. It's very slow. So why do I say that? So the real estate industry is, as we all know, very conservative and notoriously slow to innovate traditionally. And this is in part because for many years, the value real estate generates has changed incrementally. It hasn't taken any great leaps. And in part because the people within the buildings and what they want from their buildings has also changed incrementally and not taken any great leaps. So when we boil that down, that means why we're building buildings and what we want from them hasn't really changed. So the value proposition for any PropTech or smart building is nothing new. It's just an incremental improvement on what we had 5 or 10 years ago. So whenever I look at a smart building, I go back to Albert Einstein, and I start by looking at the problem. What are we trying to solve? What issues is the smartness going to resolve before looking at technology? Once we have the problem and we've defined it, we can very, very quickly find the right technology to fulfill the needs. So let's just talk about corporate real estate or commercial real estate very quickly. And what do people want from buildings? So very, very simply, people want increased rental yield, higher net operating incomes, higher space utilization, higher tenant retention, etc. So these are all things that we can use smartness to improve. But we also need things from buildings. So I think we need many things, but I've distilled this down into 4 things is how I think about it. So the first is efficient and effective spaces. So this can be very, very broad reaching, but just how I traditionally look at it in my day-to-day work is spaces that will not exacerbate climate change, and spaces which are healthy and improve the well-being of the people within. That list could go on and on, but I generally focus on those 2 in most of my work. So once we've designed the efficient and effective spaces, we need to translate those design aspirations into real operational performance. And that's, in the industry, that's been really, really challenging from the very get-go, hundreds of years ago. But now, with smart technology, this is one of the elements that's getting a lot more effective today. And once the building's operating, we need the ability to optimize the performance of that building in real time. As buildings change over their life, their fundamental operations change. For instance, if you were to build a new building that was designed for 1,000 people, say, and you built it really well, it looked really good, it got lots of good press. So actually, 1,500 people moved into the building. Everything's changed about that building. So you need to be able to react to that in the real time. And finally, of the 4 things we need from a building, and this is going to become really, really important in the next 4 to 5 years, if not already, is the ability to accurately report on ESG, environmental, social, and governance aspects of performance associated with that building. You just need to type in ESG real estate into your favorite search engine, and you'll get hundreds of hits about everybody around the world trying to report the ESG. And as of yet, there's not really a standard for this, but we will see that as time goes on. Okay. So that's broadly how I see the bucket of smart buildings. I'm going to talk to you a little bit now about how TB&A approach the design of smart buildings. So as I mentioned at the start, we start from the end. So we look at what we want to get out of the building. So some of the values, for instance, we might be wanting to improve cost efficiency through reduced operating costs, reduced equipment costs, reduced staff costs. Potentially, we want to reduce regulatory risk. So we want to lower carbon emissions, have faster, more accurate ESG reporting. If I'm a landlord in a building, I might want some operational benefits. So better landlord-tenant communication, better security, value-add services, more attractive space, more efficient facilities management. And if I'm a tenant within a building, I might be looking closer to the people within the building and the space. So higher performing employees, healthier environments, improved workplace safety, and also more effective space and better space efficiency. So that's some of the values, and I'm going to cycle back to the 4 elements I mentioned at the start of my conversation here. So we need buildings to be efficient and we need them to be effective. So what do I really mean by this? I think we're probably all very familiar with the term efficiency. I know I am as an engineer. That means how much energy do we put into a building to make it function? There will be some work we put in and some waste we get out, and that defines our efficiency. But then we also need the building to be effective. So how well does the building enable the people within it to perform would be a measure of its effectiveness. So just to zoom into an example here, I'm going to talk about a school. So we can design a school to be very efficient. We reduce the facade heat loss, we use natural ventilation, etc. But often we see mechanical ventilation in schools. And to deliver the most efficient school, we would minimize our mechanical ventilation. If we minimize the fresh air, the carbon dioxide levels within the space will rise rapidly, and we'll get to a point where our cognitive performance drops off by up to 50%. There's been a number of studies that showed that recently. At typical levels you find in many schools around the world. So if our cognitive performance has dropped off by 50%, our school is no longer effective. Our teachers aren't teaching, well, they're teaching at half capacity, and the students are learning at half capacity. So our overall effectiveness would just be 25% of what it could be, which is scary. So a high-performing building needs to be highly efficient and highly effective. It uses the least amount of energy to deliver the most performance. Okay, so Okay, sorry, just lost the train of my thought for a few moments. I'm going to share a slide now, if I can remember how to. Oh no, I can't share a slide, so it doesn't matter. No problem. So I want to get a bit technical now. So I want to talk about the typical digital architecture you would see within a building, and this will contextualize what I will speak about later. So within a typical, let's say, office building, we have several subsets of systems. So we'd have the base building systems, things like lighting, HVAC, elevators, etc. We would have fit-out systems. So they could be the tenant local HVAC systems, air quality systems, space optimization systems, catering systems, etc. We would then typically have FM systems, and these can be fire regulations, compliance, might be fitness equipment, maintenance schedules, etc. And then we would probably have tenant technology specific systems, such as staff apps, meeting room bookings, food ordering, parking, etc. So these are different subsets of systems, and data will be pouring out of these systems like a fire hose and be squirted at the building, and they'll be coming up as data through various gateways, interfaces, servers, direct contacts. You know, the list is quite large, but essentially in buildings now, we want to bring all these disparate data streams up through a gatekeeper. And the gatekeeper checks and it verifies data, it does some security work, but it brings all this data into what many people have called a data lake, which is essentially a cloud server or a number of cloud servers, which are collecting, say, historic performance data, an asset database, real-time statuses, spatial layout, BIM models, etc. And what this data lake enables, it enables interconnectivity of this data. So we can reference our energy against our air quality or a number of things. And the way we do this is by using a variety of apps and platforms that can pull data from the data lake, combine it, do lots of clever stuff with it, and then feed back value into the building. So this is how we normally see digital architecture. Okay. So still on the topic of an office, I just want to talk through what three key elements that we can deliver today for offices. So this is, if a client asks me today, what can you do for me? These things are all perfectly possible. So the first one I would consider would be around energy and carbon. So we want to lower energy consumption and lower carbon emissions generally. From the point of view of a landlord, this is great because it increases my net operating income and it therefore increases my asset value, which is great news for the financial bottom line. And it also lowers my regulatory risk around carbon emissions, etc. For the tenant, it's also great news because that gives me lower operating costs, lower carbon footprint, more attractive to employees who work for me, and stronger branding in some instances. So there's lots of value there for energy and carbon. If we move on to health and well-being now, so the landlord delivers a base build that's very healthy. So this gives them, or can give them, a competitive advantage. So they can attract and retain tenants more effectively. And it improves people's health, obviously. For the tenants, they get a competitive advantage as well because it means they can attract talent and new colleagues to their organisation more effectively. Their health and well-being is improved, and ultimately their productivity improves. So great news, lots of value again. And the third element is around space optimization. For the landlord, this is great, because through offering value add services to the tenants, they can gain competitive advantages. They can help inform their workplace strategy, and they can better fit tenants to their buildings. And they might be able to also lease flex space to them as well, which could increase their overall building utilization. For the tenant, it's great because my meter squared I'm leasing is optimized. I can use flex space as a buffer, and the space I have is better suited to my colleagues' working needs, and so the space is more effective. So that's what we're trying to get to from the smart office. So when we design, we don't design for performance nowadays. So just think about how it was a few years ago. For anyone in the UK here, we have what's called energy performance certificates in the UK, or EPCs, which are a regulatory branding from A to F of how efficient your building is. But they're very broad and they're general, and they're really not an indicator of performance. So when we move buildings from design to operation, the operators do not know what to expect. So they spend valuable time and wasting energy optimizing that building and trying to set KPIs for performance. But often they don't really optimize the building, and the KPIs for performance they set, such as energy consumption per month, are not based on optimal performance. So the building is going to underperform for the rest of its life. And really, in today's day and age, there's no excuse for this. We can embed meters on equipment to measure energy consumptions and the status of them. And we can also put monitors into occupied spaces, so we can measure conditions such as daylight, space optimization, air quality within the space. So, and these meters and monitors have really dropped in price in the last few years. So now we can reasonably, at a reasonable cost, deploy these meters at design so we can understand the building. But also at design, we are running project-specific performance, energy and carbon and water and waste models, which generate us a set of operational KPIs. And these are really important. And it's not just this building will consume X kilowatt hours of energy per week. It's broken down into the subsystems. So the lighting should be consuming this. This chiller should be working like this, etc. So when the building moves from design to operation, the operator of the building have a very good understanding of how that building should perform. They have the KPIs, so they can very quickly optimize towards that point, and they can get that building up and running and effective very, very quickly. And I call that design for performance. Also, when we're going through that process as well, because we're collecting lots of data from the building, we can spot faults very quickly. There's one good example where we did at TBNA, where it was a school in the south of Wales, and the plant was switching on at midnight every day and every weekend, which for a primary school is not how it should be working. But because we were measuring all these subsystems, we spotted that very, very quickly, and we rectified it, and we saved lots of energy, lots of money, and it was all good. So just coming to the end of what I'm going to talk about today, I just want to do a little bit of a deeper dive into one of the aspects of a building that I believe is very, very important, and that is air quality. And I want to look at the 4 steps that I mentioned earlier. So designing for performance, translating to operation, optimizing performance, and ESG reporting. So if we take a typical office building, again, we would want to measure the outdoor air quality. And when I say air quality, I'm not looking for many parameters here. Typically, for a reasonable price today, we can measure PM 2.5 or particulate pollution. We can measure total volatile organic compounds, or TVOC. We can measure carbon dioxide. We can measure temperature. We can measure humidity. And these 5 parameters can give us a very good understanding of the air quality within a building. So we measure them at the outdoor condition. We then measure again just after the filtration. So the air comes into the building, it passes through some filters which clean the air, and then we measure the air quality then. And then we also measure the air quality within the space, within the building. So when we measure outdoor and post-filtration, we understand how our filtration system is performing. So are the filters working? Are we removing the amount of pollution we expected from the system? Do I need to change my filters, etc.? When we measure the air inside the space, we understand what people are actually breathing within the building, which is super important if you want to make those people happy and have good peace of mind, and we want to maximize their well-being. So we'd also want to communicate this information as well, so we could optimize performance. So we want to, around air quality, we would generally try to communicate that to the people within the building, so they understand that the building they're in is performing very well, and they can have peace of mind and go about their days happy. We'd also want to communicate things like the filtration performance to the facility management teams, so they could optimize that performance. And we might also take this data to a portfolio view across several buildings at a higher level platform again. So this design for metering through to monitoring, communicating information has enabled us to draw lots of value out of the building and increase the value proposition of that building. And just as a final thought, I just want to touch on where this all might end up in the future. And I think it's going to be digital twins. So a digital twin is a data representation of a physical system, in this case, a building. It doesn't need to be 3D geometry, it can just be a data set, that's fine. But we take lots of operational parameters from the building: physical location, vacancy, rental input, climate, outdoor weather, energy consumption, health and well-being, space utilization. And then we bring that into a combined data set, or the data lake I mentioned earlier. But we actually structure that data lake to be able to interact with each other. So we have the real data, we can have a prediction of how that should be happening within the digital twin. So we can compare real performance to predicted performance at the touch of a button. We can cast scenarios. So if I changed all my windows to have a higher solar shading component, what would that mean for the building? What would that mean for energy? What would that mean for daylight? So we can use predictive, we can predict what would happen in the future. And we can look at variance analysis against budgets, etc. So lots of really exciting stuff can come out of digital twins. And we're seeing a few in the market today, but I anticipate we'll see a lot more in the years to come. And I really think this will help us drive the original value propositions that we want to get out of a real estate asset going forward. Okay. A final note, I'm not going to talk too much about this. Elizabeth, who's up next, will be speaking about smart building certification. But just a note to say that I believe wrapping it up into a certification and using this to drive this process through design is really valuable. So yeah, that's all I wanted to talk to you about today. I hope you found this interesting. If you have any questions, feel free to ask.
Yeah, thank you, Mark. That was very interesting. Where in the world do you see the most adoption of this?
The most uptake?
Yeah.
I think there's a couple of places really. Probably your home country, Walter, would be a good example. There's a few fantastic buildings in Amsterdam and around Holland. We're also seeing lots of movement in Singapore. I think where I'm based in the UK, we're probably a touch behind the curve, but we're catching up quick.
And do you have an example of a building that you really like because of all the integrations that you've mentioned?
There's several really, but what I've not seen a very good example of yet, perhaps I haven't looked hard enough, but is of a truly integrated building. And this is what we're all pushing for at the moment, and lots of our clients are asking for is, how do we really integrate all these disparate data sets together to drive value? And what platform do we use to do that?
Yeah.
There's a couple on the horizon, but I don't think anyone has cracked it 100% yet.
Is it difficult to crack that code, to really bring everything together?
Yeah, potentially where our next tech billionaire is going to come from.
Yeah, do you think so?
It could well be. Real estate's a huge market globally. If someone gets it right, then the world's their oyster.
Yeah, and many buildings need to be fixed. What is your opinion about the difference between existing buildings and new buildings?
My opinion is centered around climate change here. If we look at most portfolios around the world, I was looking very closely at the NHS, which is the National Health Service in the UK recently, about all their hospitals and primary care facilities, etc. And you look at the impact that their predicted new build's going to have on their carbon footprint going forward to 2040 compared to their existing portfolio. And the new build element is tiny compared to the existing. Yeah. So really where the key wins are for climate change is all around making existing buildings perform more effectively and more efficiently.
Yeah. Well, I hope we can make some nice steps doing that and creating a better built environment, because it's possible with all the technologies and implementations that we can do, I think.
For sure. Technology is very much enabling us to do this now. And I think that's part of where the momentum's coming from, is people have realized the possibility of leveraging technology within buildings.
Yeah, and if we now have many more pledges from real estate owners and investors that really want to create a more better portfolio or net zero portfolio, then well, things are going to change.
I hope so.
I hope so too. Well, speak to you soon, Mark. Thank you very much, and enjoy your day.
Thank you, Wouter. Speak to you soon.